2 days ago, the United States Geological Survey added a notable quake entry to its public catalog. The magnitude was 0.0. The location was 6 kilometers north-northeast of St. Andrews, South Carolina. The flag said sonic boom. 43 hours later, the entire eastern half of Massachusetts felt the second one. A weather satellite caught a very large optical flash in clear air over the same coastline. Independent meteorologists made the call within minutes. The federal government did not. Here is what the instruments actually saw and what the silence reveals. At approximately 2:25 Eastern Time yesterday afternoon, May 30th, 2026, an explosion shook buildings across eastern Massachusetts. The first reports came in from Cambridge and central Boston. Within 15 minutes, the same descriptions were arriving from Rhode Island. Residents said the event felt like an explosion or a large object falling. Many of them said the building they were in physically shook. Police scanners in multiple eastern Massachusetts towns received calls from people who had no idea what they had just felt, only that they had felt it. You need to register what that means before we go any further. Tens of thousands of Americans scattered across 2 states simultaneously experienced the same boom inside a 15-minute window. They were not coordinated, they were not watching the news, they were not anywhere near each other. And every one of them came to the same conclusion within seconds. Something just exploded somewhere close, and nobody knew what it was. In a country with a functioning emergency communication system, what happens next is the obvious thing. Within 30 to 60 minutes, a federal agency goes on the air and tells you what happened. That is how it works for severe weather. That is how it works for earthquakes. That is how it works for tsunamis. There is supposed to be a voice that comes on after the event and says, here is what just hit you, and here is what you do next. That voice did not come on. Not in the first hour, not in the second hour. For the entire afternoon, the only people who could tell the American public what had hit Boston were a handful of meteorologists with public accounts, looking at open weather satellite data and putting the pieces together themselves. Sitting in geostationary orbit 22,000 miles above the equator is a weather satellite called GOES-19. It is operated by the National Oceanic and Atmospheric Administration. Among the instruments it carries is something called the Geostationary Lightning Mapper, or GLM. Its job is to image the entire Western Hemisphere at a single wavelength, 777 nanometers, at extremely high cadence, looking for the millisecond optical flashes that characterize lightning. At approximately 2:25 yesterday afternoon, that instrument logged what was publicly described as a very large flash over eastern Massachusetts. There was no thunderstorm, there was no convective activity, there was no severe weather signature on radar. There was nothing in the sky from a meteorological standpoint that could have generated an optical event of that intensity in that location at that moment. That is the data point. When a clear air optical flash of that brightness lights up the GLM, there is essentially one alternative source category, a bolide, a piece of the solar system entering Earth's atmosphere at high speed and at low enough altitude that its terminal fragmentation produced a brief, intense optical signature visible from a satellite 22,000 miles up. The meteorologists watching the GLM data made that call within minutes. They did not wait for a press conference. They did not wait for NASA. They did not wait for a recovered fragment. They looked at the signature, they confirmed the absence of any thunderstorm correlation, and they said publicly, this is going to turn out to be a significant bolide entering the atmosphere. That call went out across operational weather networks before any federal agency had said anything at all. Here is where this story stops being about Boston and starts being about something harder to swallow. Because 43 hours earlier on the same coastline, something almost identical had already happened. And almost nobody outside the people who had felt it knew that it had. On Thursday evening, May 28th, at approximately 7:28 Eastern Time, the United States Geological Survey posted a notable quake entry to its public catalog. The location was 6 kilometers northeast of a place called St. Andrews, South Carolina. The magnitude on the entry was M0.0. The label attached to the entry was sonic boom. A magnitude 0.0 earthquake is not an earthquake at all. It is what the USGS catalogs when its regional seismic network, the array of seismographs distributed across the southeastern United States, picks up a real multi-station signal that the network is confident in, but where the waveform is not the kind of signature you get from rock breaking against rock at depth. The signature was atmospheric in origin, a pressure wave moving through the air and coupling into the ground. The USGS has formalized this convention over the last several years. M0.0 sonic boom label when a real acoustic signal is detected by the seismic network and the source is atmospheric rather than tectonic. The agency does not identify the source of the boom. That is not the Yuskies' job. The other agencies that might have identified the source did not. 43 hours passed. No federal agency said anything about a supersonic aircraft transit. No agency said anything about a training exercise. Nobody from NASA said anything about a planned re-entry. The local news in Charleston ran a few short pieces on the catalog entry, mostly playing the magnitude 0.0 label for novelty, and the story died. Then Boston felt the second one. The moment that happened, the South Carolina entry came back, not because the agency suddenly had something new to say about it, but because the public put the two events next to each other, on a map, in a 48-hour window on the same coastline, and asked the only honest question available: what are the odds? The technical definition of a bolide is a meteor brighter than the planet Venus at maximum brightness. That is the literal cutoff. Most meteors, the streaks you see during the Perseids or the Geminids on a clear August or December night, are produced by particles smaller than a grain of rice, vaporizing high in the upper atmosphere. They are pretty, they are completely harmless, they do not make sounds, they do not shake buildings. A bolide is a different category of event. To outshine Venus, an object has to deliver enough energy to the atmosphere in a single flash that from the surface of Earth it momentarily reads as brighter than the brightest planet in the night sky. The objects that do this are at minimum tens of centimeters across, and they can range up to several meters at the high end. Their energy yields are measured in fractions of a kiloton up to several kilotons of TNT equivalent, released in a few seconds as the object structurally fails under the aerodynamic and thermal stress of high-speed atmospheric entry, breaks apart, and vaporizes. The Boston event was almost certainly not at the upper end of that range. If it had been, you would be talking about broken windows across half of New England. What the data is consistent with is something in the meter class range, an object somewhere between a basketball and a refrigerator, give or take, entering the atmosphere fast, breaking up at altitude, and releasing a fraction of a kiloton of energy as a single airburst. That seems impossibly small for what people in Cambridge felt. The intuition you need to push back against is the one that says size equals impact. The thing that makes a bolide audible at ground level is not its size, it is its kinetic energy. A meter-class object hitting the atmosphere at 20 kilometers per second is carrying the energy equivalent of a heavily loaded freight train at highway speed. When that energy goes into a single airburst, the shock wave it generates is a literal sonic event. It propagates outward at the speed of sound. It couples into the ground. It rattles buildings. The reason the boom was heard from Cambridge to Rhode Island is geometric. An airburst at 30 to 50 kilometers altitude projects a shock cone in every direction at once. For a sub-kiloton bolide, the audibility radius is well within 100 to 200 kilometers. Cambridge to Providence is about 90 kilometers. That is exactly the footprint the data shows. The reason the meteorologists could make the bolide call within minutes is that what GOES 19 caught yesterday has a clean precedent in the modern instrument record. On the morning of February 1, 2019, an object roughly the size of a kitchen table entered the atmosphere over western Cuba and produced a daylight airburst that was felt across a wide area of the island. There were no thunderstorms in the area. There was no operational weather event in the region that could have produced an optical flash visible from orbit. The previous generation version of the same instrument, GOES 16's Geostationary Lightning Mapper, caught the flash cleanly, in a clear sky region of Cuba, at exactly the time the audible boom was reported. Within hours, the GLM data was being shared by independent meteorologists, the bolide hypothesis was being confirmed by Cuban authorities, and recovered fragments were showing up on the ground in the town of Viñales. The Cuban event is the canonical example, in the modern record, of a weather satellite picking up a planetary defense event. The Boston event yesterday is the same signature. The GLM caught a very large optical flash. The flash was in clear air. There were no thunderstorms anywhere in the area. The independent meteorologist's call was immediate, public, and on the record. The instrument worked exactly as it had in the Cuban case 6 years earlier. This is, in a way, a quiet pattern that runs through the history of planetary defense. The instruments that have given us the consequential data about bolide events are almost never instruments that were built for bolide detection. The Defense Support Program satellites of the late 20th century, built to detect Soviet missile launches, caught the optical signatures of hundreds of upper atmosphere bolides over their operational lifetimes. The infrasound stations of the Comprehensive Nuclear Test Ban Treaty Organization, built to detect clandestine nuclear tests, routinely detect bolide acoustic signatures, including Chelyabinsk in 2013 at 20 stations across the planet. The Geostationary Lightning Mapper, built to map lightning, caught Cuba, and now appears to have caught Boston. The infrastructure exists, it is just always wearing the wrong name tag. The USG's magnitude 0.0 convention has the same kind of precedent. The reason the regional seismic network in South Carolina could log Thursday's sonic boom at all is because seismic networks have been picking up bolide airbursts for decades, and the canonical demonstration of the mechanism is Chelyabinsk. On February 15, 2013, a roughly 20-meter object, at the high end of the bolide range, with a yield estimated near 400 to 500 kilotons of TNT equivalent, about 30 times the energy of the Hiroshima weapon, entered the atmosphere over the southern Urals and produced a daytime airburst that injured roughly 1,500 people across 6 cities. Almost every injury was caused by shattered window glass. The optical brightness of the event briefly exceeded the sun. The Russian regional seismic networks recorded the signal cleanly. Networks in Central Asia recorded it. Networks in Central Europe recorded it. The published seismological literature on the event reads like a textbook on atmospheric-to-ground acoustic coupling. The arrival times across dozens of stations let researchers reconstruct the trajectory of the airburst. The amplitudes let them estimate the energy. The seismic network did exactly what it was built to do, even though the source of the signal was an object that had entered the atmosphere at 18 kilometers per second from interplanetary space. When the USGs posted the magnitude 0.0 sonic boom entry for St. Andrews on Thursday evening, the agency was doing the modern American version of what the Russian seismic network had done in 2013. The regional network detected a real signal. The waveform was atmospheric. The agency cataloged the event accurately and applied the standard flag. What the entry does not contain, and what the entry was never going to contain, because it is not in the USG's remit to produce it, is an identification of what kind of atmospheric source generated the signal. Was it a supersonic aircraft? Was it an industrial blast? Was it a bolide, like the one that hit Boston 43 hours later? The agency does not know. The agency did not pretend to know. The catalog entry sat in the public record for almost 2 days, accurately describing what the instruments had measured, and the question of what generated the signal was left for someone else to answer. Nobody else answered. There are 3 ways to read what happened on the East Coast between Thursday evening and Saturday afternoon. We are going to lay all 3 out in the order of how much explanation each one requires. The first interpretation is that the 2 events were unrelated sporadic bolides, both atmospheric in origin, both within the normal background rate of sub-kiloton terrestrial impacts. The clustering registered with the public because the events happened to be witnessed by populated coastal corridors. The GLM signature on Saturday is the strongest piece of evidence. The South Carolina event on Thursday was most likely the same kind of event, just without an accompanying public-facing GLM call. This is the boring interpretation. It is the most parsimonious. It fits all the published data. The math actually matters here. Earth's atmosphere is hit by an object large enough to produce a visible fireball roughly once every several hours, averaged over the whole planet. Most of those events happen over ocean. Most of the rest happen over uninhabited land. Boom-class bolides, events that produce an audible airburst at the surface, happen several times a year globally, and most go unreported because nobody was there to hear them. 2 events on the same coastline within 48 hours is uncommon but not statistically impossible. NASA's Center for Near-Earth Object Studies has logged 3 confirmed fireballs in the previous 3 weeks, over Russia, over the South Pacific, and over the central North Atlantic, all in the same sub-kiloton energy class as the Boston event. The second interpretation is that the 2 events were unrelated, but one or both was not actually a bolide. The South Carolina event in particular is genuinely under-constrained by the public data. The USG's catalog entry tells you the seismic network detected an atmospheric pressure event, but it does not tell you what generated it. Candidates include a military supersonic aircraft transit along the Atlantic coast, an industrial blast at a coastal facility, or any of several other plausible atmospheric sources. Under this reading, the Boston event Saturday is still a bolide on the strength of the GLM signature, and the South Carolina event was something else. The news framing of 2 of the same kind of event would be a coincidence amplified by human pattern matching. The third interpretation is that the 2 events were physically related, not in the conspiratorial sense, in the astrodynamical sense. The idea is that the 2 events might be members of the same small meteoroid stream, fragments of a single parent body that has just begun to deliver pieces to Earth's atmosphere along a coherent trajectory. There is, as we speak, no published orbital tie between the 2 events. The American Meteor Society has not announced a coherent radiant for a stream that would explain both. The major meteor showers visible from the United States this time of year, the Arietids, peaking around June 7th with a daytime radiant that hides them from naked eye observation, and the Eta Aquariids, which peaked in early May and would now be on the decay tail. Neither shower is known to produce boom-class bolides. The third interpretation is the one the public will gravitate toward. It is also the one with the least direct evidence in the current data. The honest position is to lay all three out, give the first as the leading candidate, treat the second as a reasonable alternative for the South Carolina event specifically, and acknowledge the third as the one to watch. Because if a third event occurs within the same window on the same coastline, the third interpretation becomes much harder to dismiss. A second framing already circulating online is that the two booms are related to something happening on the Sun, that they are precursors to a major seismic event, or are themselves caused by some kind of solar driving. This is not a crazy question. There is a sub-literature, going back several decades, that investigates whether geomagnetic conditions can correlate with seismic event timing. The most cited modern paper by Marcatelli and colleagues in 2020 proposes a framework that requires specific preconditions: geomagnetic driving from an Earth-directed coronal mass ejection, paired with active solar wind conditions, paired with elevated geomagnetic activity in the days surrounding the event. The preconditions across the May 28th to May 30th window are clean. The KP index, the standard measure of geomagnetic activity, peaked at 4 on May 29th at 1800 Universal Time. That is below the G1 minor storm threshold of 5. There were no Earth-directed coronal mass ejections in the published Space Weather Prediction Center catalog for the window. The solar wind speed at the time of the Boston event was about 522 kilometers per second, mildly elevated, not in storm territory. There was one M-class flare in the preceding 3 days, an M1.1 event from active region 4455 on May 29th. But the source location was well east of the central meridian, meaning any coronal mass ejection associated with the flare would have been directed away from Earth, not toward it. The framework conditions for a solar trigger interpretation are simply not met. The driving inputs the framework requires are not present in the data. We are not in a state of active geomagnetic driving. The sky is by standard measures quiet. That does not mean the question is illegitimate to ask. It just means the framework cannot be supported by the standard analysis on the published data. So let us address the framing the public will reach for first. The idea that the government knows what these events were and is not telling. The honest answer is the one that is hardest to swallow. The United States federal government does not have a designated agency whose job is to publicly communicate when a piece of the solar system has just exploded above an American city. There is no Bolide notification center. There is no Planetary Defense Public Affairs Office. There is no number you call when GOES 19 catches a clear air flash over a metropolitan corridor to find out within an hour what just happened. What exists instead is a constellation of agencies, each holding a piece of the relevant data, none of which has the formal authority to issue a public bolide identification. NASA has a Planetary Defense Coordination Office staffed by scientists doing excellent work on near-Earth object discovery, and it is not set up to be a real-time public affairs voice for atmospheric entry events. NOAA operates GOES 19 and its Lightning Mapper, but the public-facing identification of a GLM flash as a bolide is not part of NOAA's operational mission, which is weather. The USGS catalogs the seismic signature when the boom couples into the ground, but identifying the source category beyond the sonic boom flag is not in the USGS's remit. The FAA tracks airspace activity and can rule out announced aircraft sources, but does not affirmatively identify non-aircraft events. The U.S. Space Force tracks orbital debris and decaying reentries, but a small bolide on a hyperbolic atmospheric entry trajectory was never in any orbital catalog and is not visible to space surveillance assets until it is already in the atmosphere. Each of these agencies has a piece. None of them owns the communication. When the Boston event happened yesterday afternoon, the chain of public knowledge ran from a NOAA satellite through a NOAA data product to a set of independent meteorologists with public accounts, to a public hypothesis that this was a bolide. The chain did not pass through any federal communicating voice at any point. It worked because individual professionals, looking at open data, made the call. It did not work because any agency acted in a public communication role, because no agency is set up to act in that role for this category of event. The two events on the East Coast in 48 hours were not suppressed. They were orphaned. The federal architecture for telling the American public what just happened, when the thing that just happened is a piece of the solar system, is a structural absence. It is not a cover-up. It is not a deliberate silence. It is a category of event for which the United States simply does not have a designated voice. The implications are worse than the implications of the cover-up framing. If the government were actively suppressing bolide information, that would at least mean the information existed somewhere inside the federal architecture and was being held back by a decision. The actual situation is that the information does not exist as a federal product. It exists as a derived inference made by independent operational meteorologists with public-facing accounts, working from open data. The agency that would have made the call, if there were one, simply does not exist. Here's what to track over the next several days. If no third event happens on the East Coast in the next 48 to 72 hours, the most likely reading stays the first interpretation. 2 sporadic bolides arrived in the same week. The world moves on. The South Carolina event probably gets some kind of post hoc identification eventually, and the GOES 19 GLM catch becomes another data point in the small but growing catalog of weather satellite bolide detections that the public never hears about from a federal voice. If a third event happens, and we are not predicting one because the responsible posture is to wait and see, then the conversation shifts. The third interpretation becomes much harder to dismiss. The astrodynamical question of whether a coherent meteoroid stream is delivering pieces to the U.S. East Coast becomes urgent, and the question of who is supposed to be telling the American public about it becomes harder to ignore. Either way, the 2 booms reveal what is actually broken here. Not a conspiracy, not a cover-up, not an enemy weapon. A structural absence in the most technologically capable state in human history for the question of what is hitting it from above. The rocks were small, the next ones might not be. The federal voice that did not come on the air yesterday is the same voice that will not come on the air the next time, until somebody in Washington decides this category of event deserves one of its own. The Space Desk will be tracking this as it develops. If a third event hits the East Coast in the next several days, you will hear it here.